Hello everyone and welcome to this teaser session of the stylometry workshop at the European Summer School, the Language and Technology in Leipzig, which is actually not in Leipzig but virtually somewhere in the space, in the virtual space. And together with my colleague Jeremi Maciej, my name is Maciej Eder by the way, we'll be trying to tease you during this teaser session, showing what stylometry is and how to measure similarities and dissimilarities between literary and non-literary texts. And Jeremi will start with some theory, with some ideas behind comparing the texts, and later on I will jump in and say more about reliability issues, some of the reliability issues of stylometry. We hope that you like this session, but yeah, time to start.
Okay, thank you, Maciej. So what we do in the stylometry course is basically we treat literature like garbage, and we cut it and we count it. So I'll show you how you treat literature like a spam. So how do we deal with spam really? Just have a look at these two email messages, and you can pause the video for a few seconds and skim the text and see which one is possibly a phishing attempt and which is an email from a colleague. And after a while, you'll see that there are some red flags, like some familiar addressative forms, which is something that you wouldn't expect from a stranger. Talking about millions of dollars, quite curious, and also, of course, blessing you. Well, in the other one, you'll see some technical terms that you would use in academia, perhaps, and a friendly name. So you immediately know that the first one for sure is spam, and the second one probably not. And the spam filters, and the spam filters get this information in a few ways. So of course they can just look at the emails there. They can look for attachments, but also, the way you did it, you probably looked for some pragmatic information. So if somebody actually wanted you to do something, for example, give them your money, or perhaps some semantic information, or you could make that decision about that email, judging, by the register, by the style of the text. But what we do is quite different, really. We just throw all of that information away, and the only thing we do is just count words. And so this is a very, very general way of dealing with what you call classification problems. So a spam filter is nothing else but just a classifier. It just tells you what message belongs to which class. And we'll do similar things with the literature. So just to translate, the problems of literature into that framework of classification. You could think of authors of texts as classes. So basically you ask, which piece of work belongs to or was authored by such and such person. And, these questions come in very precise forms. For example, a couple of years ago, people didn't know who actually was the Galbraith, and they started asking questions, and one of the stylometrists, our colleague Patrick Uwala, actually discovered that this was rolling, and he did that by counting the words. You could ask questions about authorial collaboration, so actually a couple of people working on the same, perhaps a novel, and deciding on who actually worked on which part, or who perhaps was who had more dominant role in that collaboration. Of course, there are plenty of questions about legitimacy of a person's authorship, or also you could actually go for another type of classes in literature, which is, again, each class would be a person, but that person would be a translator, not an author. So again, you could ask questions about, whether you actually can find out who was the translator, if that's a signal, that fingerprint of the translator is visible there in the translated work, even though the translator should in principle give you the impression of what the author feels like in the original, some would say. You could ask about actually a translator's wife or husband, because they might have helped. Well, my partner helped me in my translation some time ago. You could ask about how many people actually were involved, and when they changed when they took changes in that translation. The one question you could even ask is, when did that translator die? And yes, you can answer that question. Jan Rubitsky, our dear friend, actually did that in one case. And now when you think about literature, about texts in its whole entirety, there are plenty of different classifications that you can come up with. So if you think about translators, there are also the languages that they translated from and to. You could think about gender of the authors. You could think about all the topics that are in those pieces, in those perhaps novels, what genre of the text it is, what type of narration, what period a work comes from, and not just literary period, but perhaps period in an author's oeuvre, in the development of the authorial style, and so on and so on. I mean, these questions are perhaps infinite. And so when you have defined these classes already, so you define that, okay, so we're interested in genres, then you can ask the question, okay, but what defines a genre, or what makes our algorithm decide that this or the other book belongs to this or the other genre? And so you can find those distinguishing features, perhaps phrases, perhaps some themes, maybe some mannerisms that belong to individual persons, and so on and so on. You can ask how these features change in time, and only then maybe you can start really interpreting, going back to traditional literary studies, how all these features that we found, how they translate to the reception of these literary works. And just to make things more concrete of how you compute these classifications, let me give you an example of authorship attribution here. So you start with three authors, A, B, and C. Let's not call any more names here. And each of those authors have produced several works, some more, some fewer. And then you have that one book that that lacks the title page, and you have no idea who actually wrote that book. So what you do, you might think of computing some dimensions, those features, and then embedding all these books in some feature space, you'd call it, and ask yourself where in that space, where in that map, that book that you want to know the author of, where that book lies. Is it close to author A, to author B, or to author C, as here in the picture? And to make that embedding, to make that space, you can just calculate characters, even just letters. You can calculate words, as we already said. Perhaps sentences, perhaps parts of speech, tags, maybe just sentence lengths, maybe just full stops and commas and semicolons. That's all right. You can, as long as you can quantify it, it's okay. And then you can also go for n-grams, so multiples of characters and multiples of words or parts of speech tags, for example. So once you have calculated the frequencies of the words, and you end up with such table like this one, so you have a list of frequencies for each book, only then you can start to think about how you calculate distances between the books. So based on that, you actually can come up with this table of distances, which will tell you how close each book is to all other books. So book A to book B, book C to book A, book C to book B, and all the pairwise distances. And then when you know all those distances, you can start to cluster the books together. So we end up with those clusters, on a map that you have seen before on the pictures with the books, right? So that's the idea. That's how you do it. That's how the computer does it, or how you tell the computer to do it. And the take-home message is basically that text can be quantified in a number of ways. You have to think hard how to do it well, and that breakthrough of digitization allows us to bring that type of research, all these algorithms to humanities. So that's our group's web pages that you can visit. You're welcome to do so. And see you at the workshop.
Well, great. We've just changed places with Jeremi, so that's the moment when I take over, and I will say a few words about some of the reliability issues of stylometry, because everyone might believe that whatever you put into your computer, the outcome, statistically solid outcome, will tell you the truth, right? Which might or might not be truth. So what I'm going to say about in this very short presentation is to show some of the reliability issues using the example of the biblical Greek New Testament. And as you probably know, the New Testament is divided into many different books, the authorship of which is disputed, spurious, and not very certain, but we can say for sure that there are synoptic gospels, so there are three gospels that are very, very similar one to another. There is the St. John's gospel, which is different. The language is different, that you can tell very easily. The Acts, so this is the continuation of the story after the death of Jesus Christ, which is sort of similar to St. Luke gospel, and some scholars claim that this is also because of the shared authorship here. There is the epistles sent by the apostles to the nations, and the Revelation, the last and the most problematic book of the New Testament, which has been claimed to have been written by Saint John, but there are some disputes which John it might have been. So using this very simple example, you can grab the text very easily from many different sources. We can try to apply a stylometric method, one of many stylometric methods. In this case, this will be multidimensional scaling. Then the name is scary, but it's a simple math behind. It squeezes the multidimensional space. Again, multidimensionality. What is multidimensionality? Welcome to the workshop. We'll try to explain what this multidimensionality is. But long story short, it squeezes the many dimensions into just two. The familiar scatter plots we, the humans, like to deal with two-dimensional, at least at most three-dimensional spaces. So here we've got the blobs of similarities, those clusters as they are very often referred to. We've got the cluster of the Gospels, the Synoptic Gospels and the Acts. We've got the cluster for the Apocalypse or the Revelation. We've got the cluster for St. John's Gospel. We already see that these are belonging to two different realms, that this is not probably the same person who wrote those two, with some asterisk and side notes, of course, but at a glance we can see that there is something wrong here. And the fourth blob, or the fourth cluster, being the epistles, quite similar to one to another. Now, when we switch from this multidimensional scaling representation into a different one, which is referred to as dendrogram, a dendrogram or a tree-like structure in which the goal is to identify different branches and leaves of these branches, and the closer they are, the more similar they are. In this picture you can find some similarities and dissimilarities, but I leave you with this picture as your homework to check, to sort out all the similarities. The reason I'm not going to discuss the details is as simple as that. If I tweak the parameters, if I use 1000 most frequent words rather than 30 most frequent words, the final picture is profoundly different. And the good question is, well, so which one is a better one, right? Which out of those two is more likely to tell the truth? And that's a very, very serious question in statistics, but also in stylometry. So which of those two is a better one? Which of those two is the one we should publish? Which of those two is the one we should rely on? If we again switch the parameters, we can reshape the final picture even more. And the good question being, so am I supposed to pick the one that simply supports my hypothesis? Am I supposed to just gallop through all the final pictures and select the one I like? Well, not really. That's not what statistics is mentioned to be. Even worse so, there is this so-called cherry picking. That's a procedure which is very unwelcome in statistics, and this is a very bad procedure of picking the final results you like. And here during this workshop we'll be showing you the ways in which we can avoid the cherry picking. We can make the procedure more reliable. There are different ways of doing so, but here during this workshop we'll be talking about the bootstrap. Bootstrap, the name is quite mysterious. Please Google for it where it came from. Suffice it to say that this bootstrap is about doing this the very same procedure many times, and each time slightly altering the parameters of the model, but doing it randomly. Right, so that's an important point here. That Bootstrap is doing the very same or approaching the very same problem with randomly altered parameters of the model in many iterations. And here we've got a list of the most frequent words in this Greek New Testament. Don't be scared by this non-Latin alphabet. The computer does not care what kind of alphabet it is. It can be, you name it. For the computer, what counts is just the strings of characters. So let's assume that these strings of characters represent the most frequent words of the Greek New Testament. And now the idea of this bootstrap could be, it doesn't need to be, but could be just picking at random, say 100 words out of this list of 1000, and doing the final picture out of it. Then putting these words back to the pool and selecting once more at random another or the same one. There are some chances, very, very small, but still the same or different selection, random selection of 100 words, and redoing the procedure from scratch. Then we put back those words and select once more 100 words, and we do it in many, many, many iterations. It can be 200, 2000, you name it. The more the better, basically, but it also takes more computation time. If you do it 10 times, then of course you need to spend 10 times more with your computer. So there is a trade-off in here. And now we've got this very, very big number of virtual pictures. We don't inspect them manually, but we can make the computer do it for us. So we perform those stylometric experiments, and here's the picture I claimed to be the most convincing, or the one that was supporting my hypothesis, that was the one that showed what I wanted it to show. And now I can confront it against the remaining 5,000 visual pictures. So I can use it by, for example, it's not the only way to do so, but I can do it by, for example, using these thermometers of truth, or the indicators how stable a particular link was in this corpus. And as you can see, some of the links were very, very stable. For example, the two parts of the Apocalypse or the Revelation turned out to be very, very stable. No matter what kind of parameters you used, this link is there, right? Whereas in some other cases, some other branches do not exist. They turned out to be very, very accidental, ephemeric. They were repeated like once, maybe 10 times, and that was it out of 5,000, right? So by inspecting those thermometers of truth, you can tell which of the links were stable and which were not. And now, of course, you don't do it manually. Don't do it with your naked eye. You make the computer do it for you. And the computer can go through those 5,000 iterations and check for the stability of those links. And then it can make those links vote, make those links hammer out the consensus. And this final picture we are really interested in. This is referred to as a consensus tree, and it adds all those particular pictures. In a way, it's not a simple adding, but this is those thermometers of truth being compared one against another, and that's the final picture which tells you the final truth about this data set. And now, as you can see, in this picture, there is a cluster of the epistles, there is the cluster of the Acts, there is a cluster of St. John's Apocalypse, and there is the three endings of three different Gospels, synoptic Gospels. There are two parts of the Apocalypse, and there is a bunch of texts. I mean, this is the beginning of Mark, the beginning of Matthew, Luke, and so on, which turn out not to be stable enough to be linked with other clusters. So they were jumping from one cluster to another, and they ended up with just being linked to the root, which means that in the case of those texts, we cannot reliably say how or where they belong to, right? So this is a tool, this consensus tree. There is a tool of saying which of the links are more and which of the links are less reliable in our corpus. And same about our course, same about our workshop. We are going to show you during this course, during those 2 weeks, what kind of reliable methods can be used to show similarities between texts. It's not going to be only about the Greek language, of course. It's not going to be about the Bible. Jeremi has just shown you some other examples. So we will broaden our scope beyond just Greek and beyond just Bible, and also beyond just authorship attribution. We'll also be interested in doing stylometry on a larger scale, but also in a scale of a single text as assessed, but also in a scale of a single text as assessed sequentially, part by part or chapter by chapter. But one of the ideas that we are going to explore is this distant reading idea of reading computationally reading thousands of texts or thousands of texts at least at a time. So in all those explorations, there will be also some fancy names used, such as machine learning, AI, which is artificial intelligence. Not so much, but still the methods we are going to rely on are very much linked to AI, a very fashionable field of study today. But this will also, all those methods will be rooted in just statistical reasoning. So if you're interested in statistics and literature and linguistics and text analysis, that's the workshop for you. And we hope that this teaser session was teasing enough to make you sign up next year for this course. Thank you very much.